Welcome to Wildcat Science with Mrs. Halgo. This is Chemistry, Chapter 5, Section 1, Part 2. So we left off talking about the forces in the atom. So looking at the nucleus, we know there's the strong nuclear force and there's electromagnetic forces. So strong nuclear force makes things attracted to each other. And then electromagnetic force, the electrons don't feel the strong nuclear force, but they definitely feel electromagnetic force. And we know electrons are repelled by each other, but attracted to the protons. And they are in constant motion, so they don't just like get sucked into the nucleus. All right, so let's talk about that nucleus. So if I change the number of neutrons, that changes the mass number, but it does not change the element. So you can have the same element with different numbers of neutrons, and those are called isotopes of each other. All right, so if you want to make this diagram, you can, but you don't have to. You could just like quiz yourself. So this would be carbon 12, carbon 13, and carbon 14. So what is the mass number of this one, and this one? Well, carbon 12, carbon 13, carbon 14. So what would be the number of protons for carbon 12, carbon 13, carbon 14? Well, it's carbon, so it would be 6 for all of them. And what would be the number of neutrons for carbon 12, 13, and 14? Well, 6 plus 6 is 12 for carbon 12, and then 7 neutrons plus 6 for carbon 13, and 8 neutrons for carbon 14. So these are all isotopes of each other. So we have our protons and our neutrons. So looking at our atomic mass, we can see that lithium, there's lithium 6 and lithium 7. So we know that lithium 6 would have 3 protons and 3 neutrons, whereas lithium 7 would have 3 protons and 4 neutrons. But why does it say 6.941? You can't have 0.941 neutrons. So what's happening here is that it's an average. So let's say for every 100 lithium atoms, you would have like mostly lithium 7, but a smattering of lithium 6. Every once in a while you'll find a lithium 8, but it is unstable and it will radioactively decay, and so it doesn't just stay around in the world. So looking here are some isotopes of elements. So like hydrogen you can have 2 isotopes, hydrogen 1, hydrogen 2. Lithium, we talked about having 6 and 7, and then coming over to carbon, 12 and 13. So some isotopes are unstable and will decay, and that is radioactivity. So it's the process by which the nucleus emits a particle or energy, and becomes a different element. This is not a chemical reaction. It does not involve electrons. This is the actual changing of the nucleus, so it's a new atom. But if we're talking about chemistry, we're talking about electrons. Chemical reactions always involve like ions and usually electrons. So what can we say about them? Electrons are negative and they are found in the electron cloud. And the element gets its properties from electrons. So the number of protons determines what element it is, but its properties are because of how many valence electrons it has. And so they're responsible for chemical bonds. And then in a neutral atom, the number of protons always equals the number of electrons. If you change the number of electrons, you get an ion, a charged particle. So let's look at sodium. Here's neutral sodium, 11 protons, 11 neutrons. It's balanced out. But if sodium loses that one outer electron, now they don't all cancel out and has a +1 charge because it lost an electron. Let's look at oxygen ions. So oxygen has 8 protons. If we look here, if it has 8 protons, 8 electrons, it would be neutral, but Oxygen really wants to gain 2 more. It has 6 outer electrons. It really wants to gain 2 more. So when it does, it's not neutral. It has a -2 charge. So oxygen often forms -2 ions. All right, electrons are very light and fast, and they are not organized along orbits around the nucleus. This is kind of the Bohr model, kind of like what we thought it was, but we know that they are just zipping around in these areas of probability of where they are as the electron cloud. Except for mass, virtually every property of the atom is determined by electrons, including how big they are and how they chemically bond. The mass is determined by the protons and neutrons. So here are some pictures of atoms, and please write this down. The size of the atom comes mostly from the space that's occupied by the electrons. So we can see here the size of the atom is the size of its electron cloud. And then please write this down. The mass of the atom comes from the nucleus. So how many protons and electrons, that determines what the mass of the atom is. Okay, so what happens when you change the number of protons? Well, you get a different element. The number of protons is the atomic number. So 6 carbon, 7 protons in nitrogen, 8 protons in oxygen. So what happens when you change the number of neutrons? Well, you get an isotope. What happens if we change the number of electrons? You would have an ion. In summary, we go back 2,000 years to the ancient Greeks, Democritus, and he developed the idea of an atom. And then to the early 1800s and to Dalton, where he came up with the modern atomic theory about atoms and how they are of different elements are the same, and of the same element are the same, and of different elements are different. And going ahead about 100 years to Thomson and Rutherford, and we discovered the electron and the nucleus. So we know the size of the atom mostly comes from its electrons, and the electrons are important for the properties of an element and its chemical bonding tendencies. And then we know the neutrons and protons create the mass, and protons are responsible for the identity of that element. And that is the end of 5.1. I will see you in 5.2. Bye.